Hello. Yeah, I'm Swav. I was an Android lead at the app business for 5 years, and then I got promoted. And I enjoy it a lot. So so that's what I do now. And quickly to what we're gonna do. I'm not preparing slides because slides are boring. I'll be just going through the code base and just showing you step by step how the widget generation can be accomplished on Flutter, how the actually code generation can be accomplished on Flutter and Dart, and we'll have fun with this. Please, if you find something strange, difficult, ask questions straight away. I'll try to answer them if I can. If not, I'm going to ask him. Yeah, so that's it. OK, so I'll be sitting here. I should see my computer better. And that's my... I don't know how to do it. Bottom. This? No.
In the settings.
OK.
Team. Preferred color team, and then you can pick whatever.
Light. Oh, yay. Perfect. That's the first one. OK, good. OK, so code generation. Why you do code generation? Because you're bored with the stuff you do every time and again, and you want to have it automated. You like your time to be spent on something that you really care about, not about doing the boring stuff. So I created a boring widget. So the code setup, you need 3 packages to do the code generation. One, it will be, of course, the sample itself, which builds and uses actually this. The second one will be the boring widgets, which will be just an annotation which we'll be using. So this is the annotation we'll be using in our code. And then you need the generator to do the job. And the example, as I mentioned. Why these two are separate? Now, separate because in the executable itself, you will only use this one. The way the YAML file works is that you will specify your dependencies. So you see here, this is the boring widget, because I won't have this annotation in my project. But what I don't want to have is having actually the generator in it. I want to have it in my dev dependencies, which will be just during the compile time, not during runtime. This is why they are in 2 different places. So looking at this example, the things obvious, yeah, this one and this one. Also need a build runner. And that's roughly about it here. Now, what we are going to achieve, we will try to essentially have a code, have an annotation, which when put on top of the model, will generate a widget from it directly. So this is why this widget is called a widget, as I've described before. So every time I will do it, it's going to create it. You may find already something interesting here. Why create a class with a constant constructor and then actually create an instance of it? Because if I don't, then in annotations, I have to use actually the call to constructor. So my annotation would look like something like a boring widget and brackets. I don't want to do it because I like to have it short, and I don't need parameters for this one. But there are instances when you actually want to have in your annotation some parameters to, like, for example, you want to build some kind of retrofit library, and any Android guys here. So yeah, so it's essentially you want to pass some parameter to the annotation processor to do something specifically. This time I don't. I just want to create a simple widget. And the result I want to create is roughly something like this. So it's a widget which took the same parameters as the class and then created a column with these texts actually stating what the state of specific property is. So yeah, so this is the main setup for the project layout. Now the interesting part is this one, is the generator itself. So what you may notice here, there's already another YAM file in the project, and this is very important because this one actually defines how the builders will traverse the code base and try to build something. Apparently, we have the way to work with multiple processors at one time, so they all can be composed into something more elaborate. This is a very simple one. This setup, one thing I haven't mentioned is actually very important. Yeah, so this is not my work. This is Jorge Coca's work, which I have seen his blog post and just took it over because he couldn't finish. So yeah, thanks to Jorge. Yeah, he leads, I think, Chicago, yeah. Yeah, and so he managed to do 2 steps. I'm showing you the third one. And yeah, and he explained very nicely that we can do more elaborate things here. I'm just stating that I want to have just one boring widget factory here, which will be just the only processor running. This is how the class will be named when it's actually generated. Actually, I don't know why this one doesn't work, because it generates just simple name. Okay, thank you. Thank you for, yeah, that's good to know, because, yeah, I was surprised why it's not named. It's just the, yeah, because my classes are actually just named G. Yeah, so event G class. Yeah, when you create your classes that you want to use in a generation, it's important to actually state that they have a part, right? So it has a part, and then when this thing is generated, it has as a part of. This thing is generated. We don't write this one. We write only this thing, and it's important to actually put it here. So yeah, so this is how the example looks like. So now let's look into generator. So as I mentioned, yeah, we have a dependency here on, because I want to know what the annotation will be. They will be creating, so it is added, and then we have a build file which tells you actually how the generator will work and how it is named. So let's look into the class which actually defines the builder. You see very simple lambda here. We just create this boring widget, and this boring widget is actually mentioned again here. Here, yeah, that's it. That's the name of the class, which actually goes in here. Name of the function which goes in here, and this one actually gets the should, and as a parameter it takes the generator that we created. We also name it nicely. So let's look into the most cool stuff, is the generator itself. Generator, in our case, had to do 2 major things. One, traverse the code, because, we don't have an inspection here. So we don't have a reflection here. We're not running any runtime to figure out what the class does or have. We just going through a source file. Yeah? So this is the one thing is that we want to inspect essentially the source, and a second we want to do something with it. So the way of doing it is to use the generator for annotation. There are other generators for files, I think, and other things. So you can generate some source code from things like JSON file or whatever, XML even. Hope so. Yeah, this one works from the class. So you can see that actually takes the boring widget as a generics. It's our annotation. So this means that it will essentially react to every time it's find in a source code the class annotated with this annotation. And it has a one nice method, generate for annotated element. And the parameters here, which are in this call, give us a way to get through the source code and get from it everything we want. So here's this nice code here, but I'm going to not go for it now. I'm going to go for this one. So let me quickly get a terminal and just revert the changes. Yeah. OK. Yeah, so this is the poor man's version of it. So what we're going to do in our private method generate widget source. First, we will instantiate something called a visitor. Visitor will visit a class, which means it will, every time the generator will encounter something in a class, it will trigger the specific method on a visitor. We will use this to register what we found about the class. So you can go for element visitor, but this one has like dozen of methods to overload. Very nasty if you don't do this. So simple one has just a very very easy way to get out of it because it just returns nulls from everything. So we just override the ones that we actually care about. And we care about two of them. One is visit constructor element. For some reason, I couldn't make visit class element work, so it didn't actually detect the name. So I went for constructor. It should have the same name as the class. So I think this one will work. And as you can see, it passes this constructor element, and I'm searching essentially the return type of a constructor, which should be the class itself. So this way, I will store it as a dot type and have it for later. Then the generator will work through other things. We'll probably find some methods, maybe not. Actually, our class model doesn't have any methods apart from the constructor and the fields itself. So the next thing it's going to trigger is that I'm going to trigger this visit element field element. And this field element has its name and a type. And what I'm going to do here is I'm going to store the names of the properties in the model against their dart types. So essentially, each property which was in the model, it will register its dart type for later use. I could create some other class to do that, but I thought this was actually very bare bone and, yeah, pedal to the metal. Yeah, and yeah, should work. So with these two things, from the visitor, once it runs, we should have enough data to actually start building our widget. So this is the first step. Instantiate the visitor that we actually have seen now. And then we ask the element, which is the class, visit my children using this visitor. So it will try to run through this class in every possible type element, method, annotation, documentation, field, whatever you can think of, and possibly trigger something in our visitor. So our visitor can be much more elaborate, can detect annotations, as I said, documents, and change them, for example, and do a lot of stuff. And once it's done, our visitor already has all these data acquired, and we can start using it. And then it starts the boring part, which is, yeah, we just go very, very simple way. We will try to create a string which represents the class with all the data that we accounted for. So yeah, we're going to start with a keyword class. We'll ask for a class name and add the widget on the end. Why we add the widget? Because we cannot have another class which has the same name as a class we started annotation from. So if we have an event, we have an event widget. If we have a user, we have a user widget. And this class extends the stateless widget. And we open the curly bracket, and of course, we close it on the end. What is good actually, when you're writing this, is to first write what you want to achieve. So you write your generated class as it should be, and then put it into comment. And then write these things by copying and pasting the lines of the code that you want to go for. So yeah, we created the class. We started to, this is a constructor. Yeah, first line of the constructor. And we iterate through our fields that we gathered to get the parameter names, and we add them to the this.parameter name. We finished our constructor. Actually, I split this into two pieces. Actually, Philip, during the show, he was actually writing in a one builder, and it was actually good enough. So I don't know if we have to have a separate builders. So this is the constructor. Constructor is done. Now we go through properties again, because we need to add the fields as the parameters we added in a constructor. Because if we don't have this part, probably it won't generate at all anything. So let me get my quick hook. Yeah, this is the magic command that you use, and it's in a README file here, so please use it. And actually, the other one is watch. So the moment that you actually create your generator and you're happy with it, every time you modify any of the annotated classes, it will run this automatically for you and generate it. So it doesn't have to be manual process every time. So I will switch off this part and try to run it. And actually, it won't run here because I'm not in the folder. Yes, cd example. And now try to run it. So one thing which is what? Huh? Oh. Yeah, because I was running this. This is the master, not the. Yeah, and let's try. So one thing you will encounter very quickly is that you don't get any results. You don't get any results because you make a mistake in your code generation, which causes essentially the build tools to not actually create a file. So how you go around it, you put your stuff into the comment. So essentially, you make your builder on the end return not the string, but actually the comment with the code in it. So actually it built it. I mean, it says it built it, which is kind of interesting. Yeah. So when it fails, because sometimes it fails, like for example, you don't have a closing bracket or something, then actually this class won't be generated at all. And then you actually see the problem. So you see, I've disabled this part of generating the fields, and it complains it doesn't have our fields, it doesn't know what the types are. So let's go back and get it back online and try to run it. I should actually do it. There's also some magic commands to do the cleanup if you have to, but I think we don't have to. Now let it finish. Questions? Yeah, it takes some time, but when it starts to run actually in the background, it's actually more fun because you're just typing and you see the results coming. It takes surprisingly long because you used to hot reload, right? Yeah, it's a code generation, so it takes more. Okay, so let's see it now. Okay, now it added the final elements here. So all the magic here, which is happening, is iterating through the fields that we gathered before. This time I'm iterating through the fields, and this is the part. Actually, this is the third one. Sorry. So first one I'm iterating through them want to have a parameters in a constructor the first time. The second time, when I want to create the fields, the final fields, so these guys here were generated from exactly from this string. And now you see my cheeky way to actually storing the property and the type, right, in a one row of the map. Yeah, so one key value pair. And then we add override build widget, build context, la la la. I've added some padding for fun. So this is where the fun starts, once you have it running. Once you have it running, it's like you increasingly make this more flexible and nice. So you start to add things, and then you essentially multiply your time by, this is how many times you actually had to retype it on, do it again on other widgets. So this is when the fun starts. And here we generate widgets. So you can see that we have a column with children and an array, and in each array we add the text with a property name, and this is the cheeky thing. So you can see that I'm escaping the $sign to be printed. So when the class is generated, it actually adds this here. Yeah. So we have a name of the property and its value. Yeah, it took me a while to actually get this one right. And then you close everything as it should be. So because you can see here that I created another string buffer just for this array of text widgets. So I'm adding them to the main on it. But to be honest, you can write actually directly on it. This code is not efficient in this respect. Yeah, and that's it. And your code is there. So now as it actually is there, I can go to the event, and I can add another final field. Maybe. Then probably I need it in my constructor as well. Yeah. And this should be fine, apart from the fact that my call here won't be actually running correctly because it will generate the need for another parameter. So, okay, I've changed my event. So let's rebuild it and see what happens. Yeah, that's my country. Here, yeah. So now this complains because it doesn't have a parameter which requires, and which parameter this was? Last one. Okay, cool. So let's go last one. And we add here US. And this was, yeah, this was in US. Okay. Does it still complain?
Second
one. Why?
Go back to your.
It takes order from the fields probably, not from constructor parameters. So you should do as the second one. Correct.
Go back to event.dar.
Yeah.
Move final string country down to the bottom.
Then.
Oh, okay.
Or yeah, whatever.
Because we iterating through this, that's why, yeah.
You need to rerun the builder.
Yeah,
Sorry.
yeah. Good. It wouldn't happen if I had the name parameters, right? Yes. Okay, let's go again. We have it here. Okay, let's go to the main. Now fine, and let's add it. US. Okay. Yay. Okay, so yeah, and that's it. So I can be actually, yeah, I'm prepared. Good. So we can hopefully run it. I don't know what I'm running right now because I can't see here. And I'm using simulator. I've learned my mistakes to not use emulator during, yeah. presentation. No, it's usually, I don't know if you've seen Emily and Matt performance during Flutter Live when the ADB decided to not connect. And they were building widgets in a 12 minutes time and they couldn't actually do anything. So that's country US here, so you can see it, and we can go and modify this. Yeah, so this is the Pursman version, because what I haven't covered with Philip back during the show was actually you can use something called Code Builder. And do I have my checkout here somewhere? Come on, checkout. No, I don't. Branch. I need to figure out where I left it. Okay, that's the guy. Yeah, and check out. Why do the same mistake as he did? Git checkout.
You need to stash your changes or remove them.
Oh, a little bit. Yeah.
You said hard.
Actually hard. Ouch. No.
It's for reset, not for checkout.
No.
You
Okay.
reset.
Yeah, you're right.
You forgive it because you have a center.
Yes.
You feel the pressure right now.
Yes. Now you can see it and check out feature aborting. All right. Oh, my love. Now I am, yes.
Reset dash
Yeah, git reset.
dash Q capital S. One word. No space.
This.
Yeah, should do. Oh, maybe not.
Anyone?
Status? Git status? What
Yeah.
Git reset dash dash R.
Yeah.
Git clean.
Okay.
Stash one.
Just do git clean and minus F.
Again?
Git clean minus F.
That's one. FD.
Okay. Thank you. Who else? Every single one. Okay, I'm gonna go and simply destroy. Yeah. No, it'll be check out.
No. Git clean FXD?
This, yeah.
RM minus RF. RM minus RF. RM minus RF. Stash won't work because it's not checked in.
Okay.
You can do git. You can git add dot and then git stash. Dot and now git stash.
Jesus. Wow. Hardest. Yeah. This is the stuff you don't do, and then you end up, yeah. So what's the cool kids way of doing it? Is use some library for it, right? So let's have a look. So we will look into generator package and YAML file here. Is it? I don't see it. No, not this one. This one. Yeah, code builder. So this is essentially object-oriented way with some builder pattern to build code. Is it good? I don't know. I'm going to show you why I don't know. So the idea is that it will provide you a number of classes which will create fields, functions, methods, constructors, everything. The thing is that it's so elaborate Actually, the previous example is neat in comparison. So let's start. Okay, so we've done the previous funny stuff. So visitor children, yeah, we got all the data, and we start with a boring widget, which is a class. And the class takes essentially the lambda, which will pass the builder, and you will, on this builder, add some extra stuff to it to make it actually have some meaningful data to use in a generator. So for example, we'll set a name. Did I hear a question? No, okay. You will set what do you extend from. This is a very funny way to make a reference quickly. So I've just passed this, and they'll figure out, okay, I need a class of stateless widget to be added here, and I have a fields, and then I'm adding them. And this time I'm adding them by iterating on the collection of my map and doing it. So you start to see the complexity of it, because every single place you'll be adding it, it won't be a string that you're writing or build method with override annotation or something like that. You'll have to actually put all these things into the builder, and it gets complex over time. And in the end, when you have to write the code itself in a build method, this is the way of doing it. So it's like, in the end, you go to the string and you add it as well. Yeah, you could do statements here, but for God's sake, it will be even harder to do it. Because imagine this, that they have to go through these builders for every single declarative way of doing it. So there has to be a simpler way of doing it. I don't know where it is. So this part is good because you can abstract it and put it, write the tests for it. It's cool. But when you actually write the you actually write the widget itself is not as clear. So this is probably why the guys put something like code in it, so you can actually essentially have a literal and everything in it. So yeah, it's not perfect tool for doing it. It requires much more, but it gives you some level of confidence if you want to run tests against it, because you will run it and say, oh, is this what my generator is doing, right? So your test will be very simple, because you're going to write, okay, this is the string I should get. This is my builder, run it. What's the result? Oh, it doesn't match. Okay, and you fix it until actually it matches, right? So that's how it is. So this is the ugly part. So you've seen it. And that's about it. The fun part is when you have a real scenario and you start to essentially have this another for, oh, I could add this and that. And this is where your saved time on generations start to actually accumulate. So if you run it once, and if you created it once and you're using like this, it's okay, it's fun, but it starts to actually play a lot when you start to add things to it. So you have your generated widgets. Let's say you want to generate what's our retrofit Dio?
Data access option.
Yeah, Dio. Is it Dio class library? Yeah, Dio library. Yeah, if you want to generate like your Dio from JSON, you write it once and you start to add things to it and make it more elaborate, and then actually your performance is improving, and you have a very sophisticated tool. This is toy right now, what you've seen there, but it gives you the basis actually what you can achieve. And all these things are in Flutter toolkit itself. I don't use any extra generators. I don't need extra processors added to the Gradle file to do it in Android KPT or whatever is now, what they now use, I don't know. Yeah, it's all already there. So go and use it. If you find a nice use case, just write it down, because everyone will use it. Cool. No questions. Oh, I have a question. Thank you.
One question, Simon.
Thank you, Simon.
Not a question, but a comment. If you go back to the code,
on the left, under boring widget generator, you'll see Dart tool, the first folder.
Oh, this guy.
Oh, you can do one from example. It's fine. Inside that,
Yeah. Yeah.
build entry point, I think it is. Build.dart, open that up. That's the code that actually runs your generator. You can actually debug it by running this as Dart debugger. So you can actually step through your generator to debug your problems.
Yeah.
That's good.
Which is very handy to know.
Yeah. Yeah, but yeah.
So just by running the build file as they were.
You can just run this same. This is what the builder actually generates.
Okay.
And then just run. You can just run this code, and it'll do what the builder normally generates for you.
So
Yeah, sorry.
generate the generator and then run generator.
This is the actual build runner tool generates this file and then runs it.
Okay.
So you can just run this file yourself to debug your generated code.
Mm-hmm.
To debug your generator, sorry.
Yeah. Yeah. Now I prefer to like a very bare bone approach, which is essentially sending your stuff to the comment and see actually what's in it, what's wrong with it. What is interesting is that you've noticed that the generated code was formatted, and this happens actually when it's everything all right with the code, because if it isn't, then actually it's not formatted. But very often, if you do something horribly wrong, especially with closing brackets, missing comma, missing semicolons, it won't be generated at all, and it will just throw you an error. And this is why it actually sending this to the comment is so, because you see entire result there. Yeah.
Do you debug it that it traps the exception?
Okay. Okay.
Another point, you said you couldn't debug the class generator? You had visit children, not visit element. So if you change it to visit element, it would visit the class first and then visit the children of the class.
Yeah. Okay. Thank you.
He is called the Whisperer. Does anybody else have any criticisms of Swav's work?
Yes. Yes, please do it. You'll be next.
What do you think about the Mobix approach for code generation?
I haven't actually used Mobix, so it'll be a very short answer.
Yeah, you need to open the GitHub to see how they do it.
Okay. Yeah, I haven't. Yeah, I've just used the tools actually I've spotted on Jorge blog post, and find that actually this is good enough. I've seen as a commercial use of code generation in a very interesting environment, which was essentially backend built at the same time as you building your app, which means the API changes from hour to hour, and so what was the use case? This wasn't actually Flutter itself, it was Android and iOS native. The backend was GraphQL, so it could do anything with it. And what we come up with is that essentially guys who build the backend, they update the template for a GraphQL, and they put a JSON schema with the parameters. And we were generating the retrofit classes from it to do the requests. And it was completely automated. So the cycle was that Dave made a change, it automatically built this and our tests were blown up because our list of parameters was not right, so we couldn't even compile the code to run tests. And then we look, this has changed, we have a new parameter in a request. We add this, and it actually works again. And this actually insulated us from any spooky change to the backend. And whose fault this is that we don't read this value, right? It's no one knows until the release comes in, and you have a massive regression, lots of bugs to do. So it was a very effective scenario and saved us a lot of time. So I'm not saying that generating widgets will be the primary use case for code generation. I think actually the business classes will be more grateful subject. Yeah.
I was just going to say you can actually, I've actually used code generation to generate vector drawing commands from SVG data paths. So you can actually do a lot more than just widgets, right? So you can, anything you can think of that you normally would code, you can use code generation to do it for you. There's also, good point mentioning is that the build runner command now is going to be run by the Flutter tool itself, when you build your project. I don't know if that's reached stable yet. I think it's in dev. So I'm not sure if there's an extra flag. I think you have to pass an extra flag. Yeah.
Mhm.
So there shouldn't be any need to run the build runner command separately anymore.
Yeah.
Anybody else got any questions? Anything? No? Okay, right. So we're just going to pause for a moment. Swav, if you
Yeah. Yes.
Peter's going to come up, but like quick round of applause for Swav.
Cheers. Thank you.